Good day, students. Welcome to the Algebra 2 CST review, part 1. We're going to be going over questions 1 to 20 of the CST review questions. Remember that this document is accessible online on the CDE website. Just Google CST review questions and then Algebra 2. You can find it. Let me demo that for you real quick. How to do that? So you can go to Google and then just type in what's this? Type in CST review or released questions algebra 2, and the first one should be it, or you can go to CST test questions and then you just scroll down to algebra 2, and that's the document that I'm working on. So you can access it, print it out, and use it for your reference, okay? All right, so let's go ahead and get started with number 1. Number 1 says, what is the complete solution to the equation? This is an absolute value equation. Remember the definition of absolute value is the distance from 0 to the left or to the right. To the left is negative, to the right is positive. So absolute value of 3 minus 6x equals 15. You have to be really careful with the signs here. There are a lot of sign tricks here in the Algebra 2 CST. So absolute value means distance from 0 plus to the left or to the right. So this quantity, the magnitude of this quantity from 0 is 15 to the left or to the right. So to drop the absolute value of ours, I'll replace it with plus or minus. Plus or minus 3 minus 6x equals 15. Now these are two equations in one. One is to the left, one is to the right. So I will do the negative one first. Negative 3 minus 6x equals 15. Or 3 minus 6x equals 15. So this equation is 2 and 1. So I split them apart so I can do one at a time, okay? So on the left side, I'll distribute the minus to the 3 and to the 6. So I'm going to have negative 3 plus 6x equals 15. And then let's solve this. So you add 3 to both sides. Add 3, add 3. You have 6x equals 18. Divide both sides by 6. And you get your first answer, x equals 3. Alright? And then let's solve the positive part. Subtract 3 from both sides first. You have negative 6x equals 12. Divide both sides by negative 6. And you have x equals negative 2. Remember, positive over a negative is minus. Whenever you divide in numbers with different signs, you always have a negative, okay? So our final result is x equals negative 2, or x equals 3. Final answer is B. Okay, so the answer to number 1 is B. Alright, let's move on to number 2. Number 2 is the same process, but if you look at the options here, we're going to get a fractional result which has been converted to decimal form. It says, what are the possible values of x in the equation absolute value of 12 minus 4x equals 2. So for this one, replace the absolute value quantity with plus or minus 12 minus 4x equals 2. Okay? Just like we did before, absolute value means distance from 0 on the number line to the left, from 0 on the number line to the left minus, or to the right plus. Okay? So we're going to split this up. Negative part, 12 minus 4x equals 2, or the positive part, 12 minus 4x equals 2. Okay? So now on the left side, we're going to distribute the negative to the two numbers, and that gives us negative 12 plus 4x equals 2. To finish this off, we're going to add 12 and divide by 4, okay? So add 12 to both sides. And then you have 4x equals 14. And then you divide both sides by 4. And then you have x equals 14 over 4. This can be reduced, right? Divide top and bottom by 2. So if I divide this by 2, I get 2. And divide that by 2, I have 7. 7 over 2 in fractional form is 3. 2 goes into 7 3 times, remainder 1, 1 half. 1 half is 50 cents, right? So 3.5. So our first answer is 3.5. Alright, so if you look at the options we have right here, you automatically can tell that the answer is D because that was the only one where x is 3.5. So our answer is D, okay? But I'm going to go ahead and finish up the problem just for kicks, okay? So let's do the right part. So I'll subtract 12 from both sides, subtract 12, and then you have negative 4x equals negative 10. Because whenever you add in, if the signs are different, you subtract and keep the sign of the bigger one, right? Divide both sides by negative 4, and then you have x equals minus of a minus. If you divide the same sign, you always end up with a positive, okay? 10 over 4. That can be reduced. 2 goes here 2, 2 goes here 5. X equals 2.5. Let me write it as a fraction first. X equals 5 over 2. 5 over 2 is the same thing as 2.5. Okay, so our answers are, we already knew this, x equals 2.5 or x equals 3.5. Okay, and then the final answer is D. Alright, let's move on to our question number 3. Alright, so let's take a look at number 3. Number 3 says, for a wedding, Sharita bought several dozen roses and several dozen carnations. The roses cost $15 per dozen and the carnations cost $8 per dozen. Sharita bought a total of 17 dozen flowers and paid a total of $192. How many roses did she buy? So we're going by dozens here, okay? So don't let the dozen fool you, okay? There are no 12s in this problem, okay? It's just a group of numbers, okay? So roses and carnations. So let's assign our variables. Let R be number of roses. R be number of roses. Okay, my R looks a little bit weird. And then let C be number of carnations, okay? So we're declaring our variables right here so we can start making substitutions, okay? All right, so let's see. The first equation has to do with quantity, okay? So basically, R plus C is going to tell you the total number of flowers she bought. So she bought 17 dozen flowers. Okay, so R plus C is going to be 17. Note that when I say number of roses, we're talking dozens here, okay? So please don't get confused. And number of carnations here, we're talking about number of dozens, okay? Multiples of 12. So R plus C equals 17, so R dozen roses plus C dozen carnations, 17 in all. And then how about price? Remember, price is basically quantity multiplied by the unit price, right? That's what basically gives you the total price that you're gonna pay. Okay, so we're gonna be looking at the total price of each and then the combined price of both of them, and then we're gonna use that fact to generate an equation. So the price we're gonna have, let's see, price of the roses is 15, so we're gonna have 15R. This is the total price for roses plus carnations is $8. This 8C equals $192. Okay, this is the price equation. All right, total price. Now we can solve this. What do we want to solve for? We can solve for R or C, but let's look at the question. What does the question ask for? It asks for roses, so we're basically looking for R. Okay, so let's solve for R. The two ways of solving this equation, we can use elimination or substitution, but how about we just eliminate C and get R, and that will be a final answer. So I'm going to use elimination here to basically solve this equation. So to solve this equation, I want to eliminate C. So how do we eliminate C? We got to make opposites, right? So what is the opposite of, I want to make these two opposites. So basically I want to make the coefficients the same and make them opposites. Okay, so put a 1 in front here. What is the LCD of 1 and 8? The LCD is 8, right? So I can change this to negative 8, the negative opposite of this, and that'll be fine, okay? So what I'll do is multiply the first equation by negative 8, and I'll distribute that to everything. So that gives me the equation 8R plus 8C equals 17. Oh snap, I messed up. Let's do that again. I forgot to distribute a minus. So negative 8R minus 8C equals negative 136. Okay? And then the second one is unchanged. 15r plus 8c equals 192. Okay? Let me write it down here so it's obvious. So we have negative 8r minus 8c equals negative 136. And then 15r plus 8c equals 192. Now these two are now opposites. If you look at the c's, they're now opposites. That's what I wanted, right? Because when I combine them, that's what they're going to get eliminated. So when I combine them, these two cancel out, and you're left with 7r equals 56. All right? When I divide both sides by 7, I'm going to have r equals 8. So basically, we're going to have 8 dozen roses. Okay? So it's all about creating opposites using the LCD as a trick, and then eliminating the one you don't want. Okay, so you have 8 dozen roses. Your answer for this one is C. Alright, so this method is called elimination. Alright, let's move on to the next example. Example 4. I said example. Problem 4. Let's see, what does problem 4 say? It says, what is the solution to the system of equations? Now, we can solve this equation by elimination, which is pretty cool. It's a very long process, but this is a CST, so we don't want to spend forever doing a problem if we do not have to, okay? So 2x minus y plus 3z equals 8. X minus 6y minus z equals 0. And negative 6x plus 3y minus 9z equals 24. Alright, so to do this, let's see. It has to be one of these answers, okay? These two, are A and B are plug and chugs, okay? Plug in and see if it works. These two, not so much. So I'm going to start with D. Infinitely many solutions means that one equation is going to be a multiple of the other. So for D, one equation must be a multiple of another. Okay. What on earth does this mean? This is equation 1, 2, 3. If I can find a number that I can multiply by any one to get another one, then that means that it's infinitely many solutions, because those two equations are going to be basically the same. They're going to be on the same line, and then they're going to have multiple solutions, okay? So in this scenario, we basically have 3 planes, and if any 2 planes intersect on a line, that means you're going to have infinitely many solutions, all right? So let's see. This one, if I multiply equation 2 by 2, do I get any of these? If I multiply this one by 2, I'm going to have 2x minus 12. Do I have 2x minus 12 here? Nope. How about this one? If I multiply this by 3, do I get another one? Oh, wait, look at this. What if I multiply this by negative 3? If I multiply this by negative 3, do I get this? Negative 3 times 2, negative 6, check. No, wait, yes. Negative y times 3, positive 3, check. Well, let's do it over here so you see what I'm saying. I'm going to multiply equation 1 by 2, by negative 3. And if I get negative 3, if I get equation 3, that means that we have infinitely many solutions, okay? So let's test it out and see. If that doesn't work, then we have to go check other options. All right, distribute everything. I'm going to have negative 6x plus 6 plus 3y plus 3y minus 9z equals negative 28, negative 24. Okay. Oh wow, that was close. This matches, this matches, this match. Oh man, this doesn't match. So sorry, the option is not D. It's not infinitely many. Had it been that this last number were negative 24 here in the problem, guess what? Our answer will be D. Okay, because 1 is a multiple of 3, or 3 is a multiple of 1. Okay, so the answer is not D. Okay, so that means we have to check the first two, 1 and 2, by plug and chug. If any of them work, that's the answer. If it doesn't, then our answer will be C. So let's try out 0, 4, 4. What does this mean? If I plug in 0 for x, 4 for y, and 4 for z into all 3, if they all work, that means that that's our answer. All right, so let's plug it in. Test equation 1. We're going to test 1 first. So for equation 1, we have 2 times 0 minus 4 plus 3 times 4. The question is it equal to 8? If it is, then we check the next equation, right? So this one is just 0, so it's negative 4 plus 12 equals 8. Absolutely is. Good. Next equation, equation 2, we're testing this coordinate, this point. 0 minus 6 times 4 minus 4, is it equal to 0? Is it? Let's see, is negative 24 minus 4 equals 0? Absolutely not. So guess what? Option A is a fail. The answer is not A. So we now have either B or C. So let's try B. So to try B out, where go my equation? That was the whole thing. To try B out, what we're going to do is basically do the same process that we just did. Plug in the coordinates and see if they satisfy all three equations. So for B, we're going to test the coordinate 1, 4, and 10 over 3. Okay? All right, let's do it. So let's test the first equation first. The question is 2 times 1 minus 4 to y plus 3 times 10 over 3. Is it equal to 8? Is it? Let's see. It's 2 minus 4 plus 30 over 3 is 10, right? Is it equal to 8? If I simplify this, is negative 2 plus 10 equals 8? Absolutely is, right? So that works. Let's test the second equation. Second equation is this one right here, equation 2. Plug these values in there. Is 1 minus 6 times 4 minus 10 over 3. Does that equal 0? Is 1 minus 24 minus 10 over 3 is basically 3 and a third, right? Man, is that equal to 0? Absolutely not. We have this monstrosity here, this mixed number here, which basically messes up the whole thing. No. So guess what? B is not a solution. So what we're going to do, if A is not a solution, and B is not a solution, and D is not a solution, then our answer by elimination must be C. So in this case, our answer is C. Basically, one of these planes does not intersect with the rest. So you don't have the planes do not intersect at a point. Okay, so that's basically what you have here. So your answer is no solution. All right. Okay. Now let's move on to question number 5. It says the restaurant bought 20 packages of bagels. Some packages contain 6 bagels each, and the rest contain 12 bagels each. There were 168 bagels in all. How many packages of 12 did the manager buy? So this is a system of equations problem. We're going to be using packages and the total number of bagels. Okay, so this is how I'm going to label them. I'm going to call T is going to be my 12 package, 12 bagel package. So T's number of 12 bagel package. I use T because first letter of 12 is T. And then I'm going to call S the number of 6 bagel package. Okay. Declare my variables so I can generate a system of equations. Okay. All right. So let's see. How many? So it says manager bought 20 packages. So the 20 packages in all, a combination of the 6 bagel and 12 bagel package. T plus S. So let's this is so the first equation is going to be T plus S equals 20. All right, this is packages, okay? All right, this is equation for packages. And then equation for bagels. Okay, how do we do this? We know that the T package has 12 bagels in it, so 12T. The S package has 6 bagels in it, 6X, S. And the total number of bagels is 168. So we have ourselves a system of equations again. All right, so the question asks for the number of 12 bagel package. 12 bagel package is T, so we need to solve for T here. So how about we just eliminate S and call it a day? All right, how do we eliminate S? We need to make opposites, right? Because if we eliminate S, T is going to be our final answer. All right, we have a 1 here. What is the LCD of 1 and 6? The LCD is 6, right? So Basically, if I can make this the opposite of this, I'll be fine. I need to make this -6, the negative opposite of this, okay? So the target is 6, so I'm going to multiply the top equation by -6, and that's going to yield 6t, -6t minus 6s equals -120. And down here we have 12t plus 6s equals 168. These are opposites, right? That's exactly what I wanted. So basically I just combine them downwards, and that's going to give me 6t equals 48. To get t, the number of 12 bagel package, divide both sides by 6. And then you're going to have t equals 8. Because 8 times 6 is 48. So the answer is 8. So B is the answer to number 5, okay? All right, let's move on to question number 6. Question 6 is going to be a graphing one, so I need to switch to the next page. Bam, they have it. Okay, so it says, which of the inequalities best represents the graph below? We'll use this graph to generate an equation, to generate 2 equations, and then we'll see which one matches with it, okay? Now for this equation right here, this is a slanted line. I'm going to use the equation y equals mx plus b as our guide, okay? Since the line is broken and the shading is downwards, okay? The shading points downwards, okay? What does that mean? If the line is broken and the shading points downwards, broken, shade down, what on earth does that mean? That means it's going to be a less than equation. Inequality, sorry, less than inequality. So what is m for this line? M is the slope rise over run. So starting from this point to this point, what on earth am I going to do? I need to rise 1, go up 1, and I need to run 1. Okay? So m is 1 over 1, which is just 1. B is your y-intercept. Where do you start on your y-axis? You start on 1, right? That's where you start on the y-axis, so your b is 1. So what is the equation of this first line? The equation of the first line is y is less than, because you're shading down and it's broken, y is less than x plus 1, like that, okay? Now this other line is a horizontal line. It has 0 slope. Remember, 0 slope is y equals some number, and then the undefined slope is x equals some number. Okay, remember x is up and down, the vertical or extreme slope, and then y by itself is side to side. Okay, so anytime you see a horizontal line, it's just a y because the slope is 0 and that's just a y-intercept. Okay, so this line is going to be shading, we're going to be shading down, right? Since it's down, inch, broken, so it's also broken. Shade down, just like the other one, guess what? It's going to be a less than inequality. Less than means broken and shade down. If I have a line here, it'll be solid, okay? Alright, so since this y equals form is in this form, this one's simply going to be y is less than -2. Alright, so which equation matches this and this? Let's see. A is greater than, that's a problem, not A. This one is greater than, it's supposed to be less than, so it can't be that. Well, this one's good, less than, and greater than, bad. That's bad. This was what made this one bad. So this one's less than and less than. Voila, our answer is D. Okay? So there you have it. Alright, let's move on to question number 7. It says, which point lies on the solution set for the system? They gave you 4 points. So we had 2y minus x is greater than or equal to -6, and then 2y minus 3x. This is an inequality, a system of inequality. Oh, right. System of inequalities. So guess what? If you have a system of inequalities, elimination and substitution are no, you can't use that for inequalities. These only work for equations, equalities, okay? Equations. This is not an equation, this is an inequality, okay? The solution to this system is is a region, not a point. These ones give you a point, but this is not a point situation. This is a region. So don't use this type of method to solve inequalities. If these were equal and equal, then you can use this. But since these are inequalities, you cannot use these two methods. Okay. So what we're gonna do here, we must plug in these answers to see which one works. Okay. So we're gonna substitute these ones to see which one satisfies the inequality. All right. So we get a test. That's the only way we can do this one. Or we're gonna draw the graph. Okay, so let's just test since we have points here. So let's test A first. A is -4 and -1. That's my x and y. I'm gonna plug it in and see if it satisfies both equations. So let's do it. So the question is 2 times -1. Be careful though. You notice that it's switched around here. Y comes first, so please do not plug in x for the first one. Okay, you gotta watch what you're doing. All right, minus -4. Greater than or equal to -6. So this one becomes -2 plus 4 greater than or equal to -6. Is it though? Because this is a question we're asking. Is 2 greater than or equal to -6? Is it the case? Yeah, 2 is way bigger than -6, right? So that checks out. Let's test the next inequality. This is the first one. Let's call this 1. Now let's test the second inequality to see if this ordered curve satisfies the inequality. So the question is 2 times -1 minus 3 times -4. Notice that it's switched around, okay, so be careful. Is it less than -6? Is it? Is -2 plus 12, is it less than -6? Is 10 less than -6? No, fail. Option A is not the answer because 10 is greater than -6, okay? Alright, next we're going to test the next set of ordered pairs to see if it satisfies the inequality. If it does, that's our answer. If not, we just keep going down the list, okay? Alright, so let's try letter B. Letter B, we have the ordered pair 3, 1. So let's see. Let's try the first equation. It's 2 times 3 minus... Oh, wait, I'm making the same mistake I said not to make. This is x and this is y. So the question is 2 times 1 minus 3 greater than or equal to -6? Is 2 minus 3 greater than or equal to -6? Is -1 greater than or equal to -6? Is it? Yes. Right? It's to the left, right? It means it's to the right. Anything to the right of a number on the number line is greater. Okay? Test the second equation. Is 2 times... Is 2 times 1 minus 3 times 3. Is it less than -6? Is it? Is 2 minus 9 less than -6? Is -7 less than -6? -7 is to the right of, is to the left of -6 on the number line, so it is smaller. Okay? Check. So our answer is B. Answer to this question is B. Okay? Alright. Let's move on to number 8. Number 8 we have a system of equations here. So let's see. Oh yeah, there you go. Okay. So it says which system of linear inequalities is represented by this graph. So basically what I'm going to do is I'm going to generate a system of equations using the graphs, and then I'll see which one matches with this. Okay, so let's go ahead and do it. So for the first one, let's do this line first. Okay, we're going to do this line first. This line, we're going to use y equals mx plus b. Remember, m is a slope, and this is a y-intercept, right? This is a y-intercept. Okay, so this is a solid line, and the shading is down. Solid shade down basically means this inequality is going to be less than or equal to. This means solid shade down. Okay, because you're shading below this line. So for this line, the slope is going to be what takes me from, let me pick a nice point. What takes me from this point right here to this point right here. I just need to go up 1 and over 1, right? So go up 1 over 1. So m is 1 over 1, which is just 1. Okay. Now, what is the y-intercept? Is where it cuts the y-axis. So b basically, for line 1, b is basically -2. So we have ourselves a combination of these three. Y is less than or equal to 1x minus 2, which reduces to y is less than or equal to x minus 2. Okay? All right. So we can cancel this. This cannot be the answer because this is greater than or equal to. Okay. Moving along. Now I want to generate the equation for my next line. So for the second line, we're gonna do the same process. Okay. So let's take a look at this line right here. This one. So for this one, hold on. It's solid, and you're shading. This is a roof, right? If this is a roof, this is above the roof. This is shade up. Since it's solid and shade up, it's solid, shade up. It's gonna be greater than or equal to. Okay. So what is m for this line? The slope for this line is the start from this point and go down to this point. So when I go down, that's -2. I'm rising, -2, which is a fall. So go down to and over 1, and I'm running just 1. Okay, so your slope is going to be -2 over 1. This is just -2. B is your y-intercept, where you start on the y-axis, which is 3. If I pull this, and this together, I end up with y is greater than or equal to -2x plus 3. Okay, so let me put my two equations right here and see which one matches. So I have y is less than or equal to x minus 2, and then y is greater than or equal to -2x plus 3. All right, so let's see which one matches. Okay, which one does this one match? So let's see. Erase all of this. That's gone. This one greater than or, oh, this is close, but this is a positive, so that kind of messes things up. So this one is gonna match. Let's take a look at these two are in standard form, so we're gonna convert these to standard form and see what matches. Okay, so let me rewrite this on the right side here. Y is greater than or equal to -2x plus 3. I'm gonna put these two in standard form and see which one matches this. Which of these matches this two? Okay, so to put this in standard form, I simply subtract x from both sides, and then I have -x plus y less than or equal to -2. I need to switch all the signs here, so multiply the whole equation by -1. That gives me x minus y is greater than or equal to +2. Okay. Oh wait, we have a match. Yay, this is the answer right here. But let's just do this just for kicks, okay, to make sure. So for this one, I just add 2x to both sides. And then that gives me 2x plus y is greater than or equal to 3. And that's exactly what this is. So our answer is D. Okay. All right. Now that's that. Let's go ahead and move on to question number 9. It says, what is the solution to the following system of equations? We can plug and chug or just solve this one. So this one looks easy to solve because I can generate opposites without too much work. Okay? 4x plus y equals -6. So you have to be careful with the signs here. What is that? This is a 3. I can eliminate, see, if you look here, all the x's, wait a minute. The x's are, these two are similar, right? I was thinking of a way to make it really easy to do. So let's see. What I'm going to do here is I'm going to basically eliminate the y's first, because that looks pretty nice. So to eliminate the y's, I'm going to basically look for the opposite. Okay, so what's the I'm going to make this 3, because the opposite of the LCD of 3 and 1 is 3, and then if I multiply this by 3, I get the opposite of that. Okay, so multiply this whole equation by 3, so I can have opposites of my y component, and then that can get eliminated. Okay, so that makes this equation 1 stays the same. Equation 2 is 12x plus 3y equals -18. So you have opposites here. All right, now what we're going to do is just combine it downwards. That's what linear combination or elimination is all about. So I'm going to end up with 14x equals -14. Okay? If I put sides by 14, I'll have x equals -1, and that's my final answer. Oh, that's nice. No, we don't even have to do any more work, because that was the only unique ordered pair with a -1 as an x coordinate. So the answer is simply C. I don't have to waste my time doing the other one. Okay, what a nice problem. All right, let's move on to question number 10. That's a long division problem. So let's go ahead and do it. So you set up our long division bars. First of all, make sure that we have no degrees missing. Okay, so 2, 4, 3, 2, 1, 0. No degrees are missing. If we had a missing degree, then we have to use a placeholder for that. Okay. So I'm gonna set up my long division bars, and then I'm gonna divide this using long division. Okay. All right. Oh, I didn't do that properly. So let's do that. Straighten up this line a little bit. So that's fine. Okay. So we have 2x plus 7 divided by 2x to the fourth plus 21 x to the third plus 35x squared minus 37x plus 46. Now, this problem does not have any degree missing. 4, 3, 2, 1, 0. If it did, you have to put in a placeholder. Okay. All right. So to do this, all you just have to focus on is basically the first number. Okay. How many times it goes into each respective term. Okay. So you ask yourself, 2x goes into 2x to the fourth how many times? Or 2x times what gives you 2x to the fourth? You know, 2 times 2 gives you 1. X times what gives you x to the third? So basically, so if I divide this by this, 2 times x to the third gives me x to the fourth. Okay, you can put a 1 here if you want, but you don't have to put it, because x to the third times 2x gives you that. Okay? So since 2x times x to the third gives me the first term right here, I'll distribute this value to both of them. Okay, so distribute x to the third to this and to that. Okay, I'll distribute it to both of them and then put my answer at the bottom right here. Okay? Alright, so let's go ahead and do that. Alright, so when we distribute both of them, distribute this to both, it's going to basically give me 2x to the fourth, because x to the third times 2x is 2x to the fourth, and then x to the third times 7 is plus 7x to the third. I'm going to add downwards. When I add downwards, well, before I add, I'm sorry, I'm going to subtract downwards. So to do that, all you just simply do is switch the signs of this, because subtraction is adding the opposite. So make this a minus, scratch that, make that the opposite of plus, which is a minus. Alright, I'm subtracting. So add downwards, this becomes 14x to the third. Make sure you line it up nicely so you don't mess up, okay? And then drop this down, and we have a new binomial expression to work with, plus 35x squared. We're going to do the same process again. I'm going to ask myself, 2x times what gives me 14x to the third? I know 2 times 7 gives me 14. X times what gives me x to the third? X times x squared, okay? Now I'm going to distribute 7x squared to both of these, this to this and this to that. So that's going to give me 14x to the third. 7 times 7 is 49 plus 49x squared. Now I'm going to add downwards, okay? So I'm going to add downwards. I'm sorry, subtract downwards or add the opposite. So make this a minus. The opposite of plus is minus, right? So scratch that and make it the opposite, which is minus. So I'm going to subtract downwards or add the opposite. This cancels out, and this is basically negative 14x squared. And then I'm going to bring down 37, negative 37x. Have another binomial, negative 37x. We're going to do the same process again. 2x times what gives me negative 14x squared? I know 2 times negative 7 gives me 14. X times x gives me x squared. So this times this should give me that. Okay, so let's distribute to both quantities here, both terms. So we can have negative 14x squared, and then negative 7 times 7 is minus 49x. Now we're going to do the opposite, okay? We're going to add the opposite of this or subtract. So minus becomes plus, minus becomes plus. We're going to add downwards. And if I add downwards, I'm going to have negative 14x. No, I'm sorry. The 14s, these ones cancel out, but if I combine these downwards, I'm going to have 12x, okay? So this is going to be 12x. And then I'm going to bring down the 46 all the way down here. Okay, so plus 46. Alright, now I'm going to do the same process again as we did before. So I'm going to ask myself, plus 46, 2x times what gives me 12x? 2x times just 6, right? So times 2x times 6, so plus 6, positive 6, distributed to both of them, I'm going to have 12x plus 6 times 7 is 42. Alright, subtract, that's going to give me the remainder. If I subtract these two, I'm going to have 4. Okay? Alright, so what we'll just do is basically subtract this from the top by flipping the sign, so this becomes a minus, and we change this plus to a minus, and then we add downwards. So this cancels out, and you're left with 4. Okay, because plus 46 minus 42 is just 4. Alright, so there goes your remainder. So your answer is going to be this remainder that. We can write it as x squared, x cubed plus 7x squared minus 7x plus 6. Remainder, positive, because this is a plus, 4 over what you were dividing by, which is 2x plus 7. Okay? That tells you that your answer is going to be, let's see, minus, plus, minus, plus, minus. Because of this minus, a is not the answer. This is totally wrong. This is wrong. Plus, minus, plus, 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 minus, plus, plus. Excellent. Our answer is D. Okay? Alright. Now let's move along to question number 11. Let's see. Question 11. It says, which polynomial represents 3x squared plus x minus 4 times 2x minus 5? I like to line up multiplication problems vertically and multiply them vertically and arrange like degrees in the same column. Okay, so it keeps me organized and I'm less likely to make mistakes. So 2x minus 5. Alright, so in this multiplication setup, I have my 0-degree term. I have my 0-degree term in the rightmost column, and this is the first degree and second degree, and it goes up to the right. Okay, so we're going to keep that consistent while multiplying. Okay, so let's do 5. I'm going to distribute 5 times all three terms on the top. Minus 5 times minus 4 is positive 20. Minus 5 times positive x is minus negative 5x. Minus 5 times 3x squared is going to be 15x squared. Okay? Alright, now let's move on to the next row. It's supposed to be negative 15x squared. Alright, so let's move on to the next row. We're going to do 2, right? Distribute 2 to everything. So 2x times negative 4 is going to be negative 8x. And then 2x times positive x is going to be positive 2x squared. And then 2x times 6 is going to be 6x to the third. Alright? Okay, so we're just going to combine it downwards and see what our answer is. So please be careful when you're working with the signs here, because that's the mistake most people make, alright? So the 6x to the third. Signs are different. You subtract and keep the sign of the bigger one, which is negative. So you have negative 13x squared. Signs are the same here. You add and keep the sign, 13x. And then just bring down 20. Okay? So minus, minus, plus. Let's see. Everything is the same, but just the sign, okay? So you have minus, minus, minus. That's wrong. Minus, minus, plus. So for number 11, your answer is B. Okay, so this problem is basically assessing your mastery of combining like terms and having the signs accurately executed. Okay, so there you have it. Alright, let's move on to question number 12. Question 12. It says, find the value of that, number 12. So in this case, we have negative 2x squared plus 6x minus, plus 1, and we are subtracting twice 4x squared minus 3x plus 1. So what I'm going to do, I'm going to combine these two terms vertically, okay, so that I can organize my terms while adding them. So what I'm going to do is rewrite the first one, negative 2x squared plus 6x plus 1. Now I'm going to go ahead and distribute negative 2 to all three terms here. Okay, so distribute negative 2 to all three. So you're going to have negative 8x squared. Minus times the minus is plus. Be careful when multiplying signs, okay? Minus times minus is plus, plus 6x. And then minus 2 times positive 1 is minus 2. And then we're just going to add it downwards. We have already distributed the minus, so what we just do is just combine like terms, alright? So in the first term, we're going to have negative 10x squared. Add these 2 plus 12x. And then combine these 2 minus 1. Okay? Because when the signs are different, you subtract and keep the sign of the bigger one. So our final answer for number 12 is D. Okay? Alright, let's move on to number 13. It says which expression is equivalent to 6y squared minus 2 times 6y is 2. Alright, so this one you can just distribute or FOIL it out to get the product. So you could do that and then combine like terms, or you can just line it up vertically and multiply. So whichever method you want. So I like to do it vertically. So 6y squared minus 2 times 6y plus 2. I'm just going to multiply, okay? I'm going to make sure that like terms are placed on the same column. So if you multiply, you're going to go distribute 2 to the top 2. Positive 2 times negative 2 is negative 4. Positive 2 times 6y squared is 12y squared. So I'm going to put that over here, 12y squared. And then 6y times negative 2 is going to be negative 12y. And then 6y times 6y squared is going to be 36y to the third. Okay, you see how I distributed everything so that the powers line up, okay? I like to put similar powers on the same row. Okay, so now I'm going to combine downwards. And let's see what we get. We're gonna have 36y to the third plus 12y squared minus 12y minus 4. Okay? So let's see. Alright, so let's look at it. These two look alike, but we need plus minus minus, so plus minus minus, our final answer is D. Okay? So number 13, the answer is D. Alright, let's move on to number 14. It says, what is the volume of the figure below? We know from geometry that the formula for volume is basically length times width times height, right? That's the formula for volume. So let's go ahead and compute this. So if you look at this shape, this is the height, this is the length, that's the width. So the volume for this problem is basically going to be x plus 4 times x plus 1 times x plus 6. Alright, so we're going to distribute all of them. So we need to multiply 2 at a time. Okay, multiply these 2 and then distribute your result to the last one. So what I'm going to do first, I'm going to do x plus 1 times x plus 4 first, and I like to do it vertically so that I can stay organized. X plus 4 and x plus 1. I'm going to multiply them. Okay, so let's do it. 1 times 4 is 4, positive 4. Positive 1 times x is positive x. X times 4 is positive 4x. And then x times x is positive x squared. Okay, now what I'm going to do is I'm going to proceed to add it downwards, out down the product. And that will give me the area of the base, so it's basically x squared plus, wait a minute, plus 4x. No, x squared plus 5x. Because there's a 1 here, right? Imaginary 1. So x squared plus 5x plus 4. So that basically is the area of the base. That's length times width, right? It's 2. But we need the volume, so we need to include the height, right? So what I'll do is I'll multiply this result I just got times the height, which is x plus 6. You're going to multiply by this to find the volume, right? Alright, so if I do that, I'm going to do the same process, just distribute x plus 6 to this whole area that I got. and that should be the final answer. Alright, so let's do it. Positive 6 times positive 4 is positive 24. Positive 6 times 5x is positive 30x. Positive 6 times x is positive 6x squared. Okay? Alright, now we're going to go ahead and distribute x to all three. X times 4 is 4x. Write that down a little bit. X times 5x is 5x squared. X times x is x to the third. And then you simply add everything down, and that would be your final answer. Okay? So when you add everything down, you're going to have x to the third plus 11x squared plus 34x plus 24. Okay? So which one matches? Wait. This one is the answer, B. Okay, wait a minute, let's make sure. 11, 24, 34, 24. Okay, it kind of looks like B. So the answer is B. Alright? So there you have it. Alright, let's move on to question number 15. Question 15, it says, what is that times that? Oh, wow. You see how the degrees are all over the place for this product right here. So we have to be really careful when we're doing the product, okay? So for this one, I'm going to arrange them using vertically and make sure the degrees are nicely aligned, okay? The reason for that is I don't want to make mistakes when I'm combining like terms. So I'm going to write this vertically. I'm going to write 5x to the third. Since there's no square here, I can leave some space, or I can put 0x squared if I wanted, and then minus 2x. And then for this one, I'm going to put, this is the square space right here, 3x squared plus x minus 8. You can do it this way, or you can distribute, okay? You can distribute just by using arrows and distribute everything. That works perfectly too, but I prefer doing it this way, okay? All right, now let's distribute. I'm going to start with 8. Negative 8 times negative 2 is going to give us positive 16x. All right, that's the first term, positive 16x. And then we're going to go negative 8 times 5x to the third. That's going to be negative 40x cubed. Okay? Now let's move on to the x one. X times 2x is going to be negative 2x squared because the signs are different. And then positive x times 5x to the third is going to give us 5x to the fourth. But we don't have anything to the fourth here, so what I'm going to do is I need to move this way to the front. So x times 5x is going to be 5x to the fourth. This is the fourth column. Alright, now let's do 3x squared. 3x squared times 2x is going to be positive 6x cubed, so it's going to be 6x to the third. This is the cube column. And then that's negative. And then 3x squared times 5x to the third is going to be 15x to the fifth. Remember, anytime you're multiplying, you add the exponents, okay? So 3 plus 2, 5, and then that's basically how you do it, alright? Okay, so there you have it. All I just do is just add it downwards, and then that will be my final answer, okay? So we're going to have 15x to the fifth plus 5x to the fourth minus 46x cubed minus 2x squared plus 16x. Okay, so let's see which one matches. 15x to the fourth, 5x minus 46x cubed minus 2x 6x. The answer is C. Alright, now let's go ahead and move on to question number 16. For question 16, we have, it says, oh, we're supposed to find what this is equal to. So basically, we have 8a to the third plus c to the third. Now, we need to go over a formula here, the difference of cubes formula. If you have a cubed plus b cubed, the factored form is a plus b times a squared minus ab plus b squared. Okay? That is the sum formula for this is the sum of cubes formula. Okay, and then if you have a cubed minus b cubed, that's going to basically become a minus b times a squared plus ab plus b squared. Okay, so there goes your formulas. So one thing you want to remember in the difference of cubes formulas is that you always have one minus and two pluses, okay? So the first sign is determined by the sign here. So you have a plus first, so you have a plus and then a minus plus. You have a minus here, you have a minus and plus plus. So you always have two pluses and one minus in the difference of cubes formula. Okay, this is basically difference of cubes. Okay? So don't forget, these are the formulas for difference of cubes. You have this mastered before the test. And then for squares, this is difference in sum and difference of cubes formula. Okay? So in this problem, we're going to be using the first formula since we have a plus here. Okay? Alright, so let's go ahead and do that. To do this, to use this formula, all you need is a and b and then plug it in here, okay? Because this is basically a cubed and this is plus b cubed right here. So what is a going to be? If a cubed is equal to 8a to the third, how are we going to get a? Just simply take the cube root, right? So you take the cube root of both sides, the cube root of this and the cube root of that. Alright? So basically a is the cube root of the first term. What is the cube root of 8? The cube root of 8 is 2. And the cube root of a is 8. How do I know the cube root of 8 is 2? What number to the third is 8? I know 1 to the third is 1. 2 to the third is 8. Right? So that tells me that the cube root of 8 is 2. Alright, how about the b part? I know that b to the third is c to the third. So what is b going to be? I need to cube root both sides. Alright, so the cube root of the second term should be what b is, okay? So the cube root of b cubed is b. Cube root of c cubed is just c. So I'm going to plug in 2a and c into this formula right here to generate my result, okay? So let me rewrite the formula so that we do not lose track, okay? So the formula basically is, I'm going to put it in red, it's going to be a plus b, it's going to be a plus b times a squared minus ab plus b squared, okay? So that's what I'm going to be plugging in right now. Alright, so let's go ahead and plug that in. If I plug it in, I'm going to have wrong color. I'm going to have 2a plus c, alright, times, let's see, 2a plus c, well, is either a or d, right? Times 2a squared is going to be 2a squared minus ab, which is basically 2ac, as b squared, which is just c squared. Alright, let's simplify it a little bit more. You're going to have 2a plus c times, if you look at the sign, you can tell that the answer is d already because it's plus minus plus, right? So you have plus minus plus, minus plus plus wrong, minus plus plus wrong, and this is, what is this? This is just so totally wrong. So you can tell your answer is even d just by looking at the signs, plus minus plus. If it were minus, it would be minus plus plus. So we know that the answer is d, but let's finish it up anyway. So 4a squared minus 2ac plus c squared, and you can clearly see that the answer is d. Alright, so the answer to this one is d. So don't forget your sum and difference formulas for cubes, because you're gonna need it. Alright? Okay, now let's move along to question number 17. It says the total area of a rectangle is 4x to the fourth minus 9y squared. Which factors could represent the length times width? So basically, this is testing your knowledge of the difference of squares. Remember, for squares, you just have difference. Okay? Difference of squares. The formula for difference of squares is basically a squared minus b squared is equal to a plus b times a minus b. Alright? So all you do is you root the first one and you root the last one, and then you do plus or minus, and then that's how you get the factored form. Okay? So let's look at this problem, 16. The reason why I know it's a square is because 4 and x to the fourth are squares, and 9y squared are squares. So that's what we're looking at here. So we're going to have 4x to the fourth minus 9y squared. Alright? So what I'll do is simply root the first one, root the last one, add and subtract the roots. Okay? So what's the square root of 4x to the fourth? Is basically 2x square, and then the square root of, and then we're going to add it to the square root of 9y squared, which is just 3y. This is a plus part. The minus part is going to be 2x squared minus 3y. Okay? So the square root of 4x to the fourth is basically, you just divide the power by 2. That's what square root is. You divide the power by 2, so you have that. Alright? So your answer is going to be option D. Okay? Alright, let's move along to, oh, wait a minute. We're on number 17, right? Why did I put 16? It's supposed to be number 17. Okay, wait a minute though. The answer is not D. So for number 17, we have 2x squared minus 3y, and then 2x squared plus 3y. So, or actually it's A. Yeah, the answer is A, because you have to square. There's a square here and there's a square there also, because this is a 4. So we have a plus and then a minus. Remember the commutative property of equality. You can also, this is the same thing as 2x squared minus 3y, and then 2x squared plus 3y. It means the same thing. Okay, so a plus b times a minus b is the same thing as a minus b times a plus b. Alright, let's move on to question number 18. Check this out. Question 18, it says, what is a product, what product of factors is equivalent to the given? Alright, so this one is also assessing our mastery of the difference of squares, because you have, for number 18, you have a square, x plus 1, being subtracted from another square, y squared. So what's the formula for difference of squares? Just to review, a squared minus b squared is, you root the first and root the last, and then you do the sum and the difference. So it's a plus b times a minus b, okay? Alright, so let's do it. I'm going to square root this, and square root that, and then I'm going to go plus or minus, okay? So if I square the first one, it's going to be x plus 1, that's my a. And then I'm going to plus it to the square root of y squared, which is just y. So this is a plus part. We also have to do the minus, okay? So it's going to become x plus 1, and then minus y. Alright? So that's basically pretty direct application of the formula. Now, if this methodology I'm using is too complicated for you, you can also say, oh, let's find a. A is the square root of the first one, x plus 1 square, which is x plus 1, because the square and the square root cancel out. And then b is the square root of the second one, y squared. So this cancel out, which is just y. And then you just do a plus b times a minus b simply is x plus 1 plus y. That's a plus b times x plus 1 minus y, which is a minus b. So this is a longer way of doing it. If this method is too abstract for you, then you can do it this way. Just find a and b by rooting the first and the second terms squares, and then you add and subtract them, and that would be the answer, okay? So you can clearly see the answer here is D. Alright, so don't forget your difference of cubes formula and your sum and difference of cubes and your difference of squares formula, okay? So all those are critical, okay? Remember also that if you have a sum of cubes, there's no explicit formula for that. A squared plus b squared. This one, the factored form of this is in the imaginary plane, so this one does not have any formulation like this to do it, okay? Alright, now let's move on to question number 19. Question 19, we have, where is 19? 19, where are you? Alright, there you are. Which example shows a complete factorization of 12x minus 147? So number 19, 12x squared minus 147. So first of all, we need to break them down and see what we can factor out from here. Okay, so let's break down 12 using the factor tree. So this is even, 2 comes out, 2 times 6. And then this is even, I can also take another 2, 2 times 3. So 12 is 2 times 2 times 3x squared. And then let's see what 147 has to offer. For 147, I can take out a 3. How do I know 3 goes into 147? If I add the digits, 1 plus 4 plus 7, I get 12. And since 3 goes into the sum of the digits, 3 must go into the number, right? So 3 goes into 147 since 3 goes into 12. So 3 goes here, 4, and carry 4, carry 2, 27, 9. Alright, and then this can be broken down into 7 and 7. Alright, so minus 3 times 7 times 7. So we're going to factor out 3 as a GCF, and then we take out the 3, and then you're going to have 4x squared minus 49. Okay, so take a look at these options right here. You already know the answer is D because that's the only one that has 3 as a fact. Come on, create it as a GCF. Okay, so you can just know that your answer is D. So let me just go ahead and finish the problem just for kicks. How do I factor this out? This is a square and this is a square. So all I just do is I use the formula A minus B squared equals A plus B, A minus B. How did that come about? We just talked about it, right? You read the first and read the last, and then you do plus or minus, right? So let's do that here. I read the first and the last, and then add and subtract the square roots. So you bring down the 3, and then you have 2x minus 7 times 2x plus 7, and that's it. That's the answer. It's clearly D. Okay? So sometimes you can just look at observe the questions, and you might not even have to do the entire thing. You can just figure out what the answer is. All right? Okay, so let's do the last one for this clip, which is number 20. Good job hanging in there for so long. We have 25x squared minus 40xy plus 16y squared. Alright, now, is this a perfect square trinomial? I can guess that it is because in these options, it looks like there's a factored form for it, okay? How do you check if it's a perfect square trinomial is you double the square root of the first and the last. If you double the square root of the first and the last, if you get the middle term, then it is a perfect square trinomial, right? The square root of the first and the last is basically 2 times 5x times 4y. If I times this together, it's going to give me 40xy. So that tells me it's a perfect square trinomial. But I can just guess that it is based on the way that these options are. So if it's a perfect square trinomial, that means that there's a factoring trick I can use. What is that? All you do here is you simply square the first term and the last term, and then you drop down the middle term, okay, and that's it. Middle sign. So what is the square root of 25x squared? It's 5x squared minus square root of 16y squared for y. Uh-oh, messed up. It's supposed to be just 5x minus 4y quantity square. End of story. Okay? So which of this match with that? The answer is A. So your final answer is A. Okay? You can use this factoring trick only for perfect square trinomials. Alright? Just read the first and the last, bring down the first sign, and there you have it. Alright, thanks for paying attention to this presentation. Do subscribe to my videos so that you can get updated clips on getting ready for the CSTs.